Hello Math 125 fans, going to try to do a short video on integration by parts. Integration by parts, I've said in the previous video, is good for products, logs, inverse trig. So I'm going to show you a quick example of each one. The vast majority of time when you use integration by parts, if you continue on past this course, is situations like this one on the left. Sometimes it's x times e to the x, sometimes it's x times cosine, sometimes it's x times sine. This is by far the most common situation we use integration by parts. And in this situation, the very first thing you do with integration by parts, let me move these over just to give myself some space here. The very first thing you do is you say, you write up this little template. Now your instructor might organize it differently. I've seen many different things. Whatever you do it the same each time. I think students don't think about this enough. Like if you're playing sports or doing activities or playing an instrument, you'd have a routine. You need to also have a routine here because that helps prevent those small errors that students complain about. I do bad math because I make math errors. If I didn't make math errors. Anyways, so what do you pick? So by now you should know that an x goes here. Sometimes I find students are still confused by that piece. The goal is to make things better. You want to put x there because the derivative, you're about to take a derivative and you're about to integrate. And taking a derivative of x is just 1. That's going to make things better as long as we can get past this step. In this case, we can. I actually stop in class and I talk about these integrals, so there's so many things, little things I can say here. But at some point, you just need to know that that's that integral. In my class, we add that to our list because you can do it with substitution, but you're running out of margin space if you have to do all these little integrals. But you can always check, take the derivative. And then we have it. These two things go together. These two things go together. You can see how I have the formula memorized by form. I smoosh these two together is what I've been saying in class. So there's some smooshing. I say that because I'm going to write it in whatever way is pleasing. I don't like to put the 1/2 between. That would look weird. Minus 0, and I'm going to smoosh these two together. Lots of smooshing. Okay, and then we're going to have 1/2 x e to the 2x, and then we get to do this again. 1/4 e to the 2x plus c. Fun. Not bad. Now, some students really like this. I'm afraid to post this because whenever I do this in class, I tell students, don't tell any other instructors I said this because they're going to be mad. Not mad. Sometimes these gimmicks aren't good. But if I were to list log, let's keep a little track, inverse trig. And I've heard all sorts of students have this. So at some point I was like, okay, I'm not going to deny this. At some point you'll know integration by parts well enough that you don't need some gimmick. But currently we just had a situation where we had an x and we had an e to the 2x. And notice we picked the thing that was higher on the Lipit scale. So u is going to be the thing that's higher here. Some of the ordering doesn't matter, but Ilpet is kind of hard to say. Okay, so now let's do another one. Let's do I'll keep this log one in the corner. Let's do the arctangent. Okay, let's put it on the Lipit scale. So even if there was an x here, I would have an x in an inverse trig. So on the Lipit scale, the inverse trig wins. But there's a reason that we do that. Now, there wasn't an x. But there's the whole reason that on inverse trig we want to do integration by parts, or we might want to try it, is because we don't know how to integrate it. We're really just stuck. Kind of the only thing we know about arctangent is its derivative. And this is something else that integration by parts does for us. dv, unfortunately, then is everything else, so it's 1. And that, unfortunately, makes that messier. But the advantage here, so we'll smoosh those two things together, uv. I always just remember it's the main diagonal and then the bottom. And your goal is to make the next row better. So you're going to get x times arctangent of x minus the integral, and then we're going to smoosh those two together. X over x squared. And sometimes students are like, oh no, but that didn't finish it. But we made progress. We got rid of the arctangent. At this point, we're then done. This requires you to go, oh no, I have to do partial fractions. But before you jump into partial fractions or trig sub, you need to be really good at recognizing that there's some important connection there. That's a substitution problem. You say, I have to do substitution and, I hate this word and. Some students in office hours use the long and to tell me what a jerk I am. I have to do this and this? If you say that long and, everything sounds bad. I have to eat a donut and wash my hands? Anyways, you just got to embrace it. Now, when I do substitution, I do it in one of two ways. Sometimes I tell students to just move the half to the other side and then replace x dx. Sometimes I have them solve for dx. It just depends on the student and what method resonates with them. But this is going to become 1 over u du. And then we're going to have x arctangent of x. There's so many little things I can say here, but I'm trying to slow myself down. Not so much. Anyways, I don't actually need the absolute value because x squared is positive. So many things to say. But I'm trying to just talk about integration by parts. Okay, so last thing. We had that log example, so I'm going to give myself some space. Let's zoop this over here. Wouldn't you love to be in my class and have me erase the notes as you're trying to write them? Somebody just posted on some online, rate my professor. They're like, oh, he's one of my favorite professors, but his writing is horrible. And I was like, oh, I don't think it's that bad. Okay, every time there's a compliment, it's always backhanded when you're an instructor. Okay, so log of 1 plus x squared. He wasn't that bad for a math teacher. Okay, so we're going to do this. Here you have to pick the whole thing because that can't be separated. So we're going to take the derivative. I remember when on this exam, the biggest error was students not knowing how to take that derivative. You still have to do the derivative of the inside, which is 2x dx. This becomes x. And you get, so we're going to smush these two things together. Smush x log of 1 plus x squared. Why am I using yellow? It looks terrible. Minus the integral. Maybe he does have bad penmanship. Maybe that student had a point. Too many ideas. I can't stop. Okay, so this one has its own challenge, but it has nothing to do with integration by parts. It has to do with how do we handle this. Now, students in my classes know that I really like when that happens because I go, well, that looks like a partial fractions, except the power on top is the same. And I actually like this when this happens. This is the one time I like long division. I'd much rather do long division with polynomials than with numbers. With numbers, you have to like think how many times it goes in. Here I know it goes in 2 times. So it's actually not too bad. 2x squared plus 2, you subtract, you get a negative 2. Remainder 2. So what does that do for me? Say, well, that doesn't do anything. Well, it does. There's 2 with 2 left over. When you're doing this, something I've noticed over the years is if your denominator changes, something went terribly wrong. Anyways, at that point, I'm done. I have it. X log of 1 plus x squared. Now, that really, again, that doesn't have to do with integration by parts. So there we go. I'm going to stop that video and try to keep each one of these clipped because there's too many other things to say, and I'm just trying to give you the idea of integration by parts if for some reason you forgot what you did 2 weeks ago. All right.